Hey everyone, hope you're doing well. Alright, let me ask you something. Have you ever just paused for a second and thought about what's actually happening inside your phone? Not just the apps. Not just the screen. I mean deep down, what's really going on underneath all of that? Because there's this one moment, somewhere between a tiny electrical signal and the video you're watching right now, where something almost feels magical. And I don't say that lightly. Today, I want to take you on that full journey. From the raw physics of electricity, all the way to how your phone can load a video, scroll your feed, play music, all in a split second. No complicated jargon. No boring textbook explanations. Just how it actually works. And I promise you this, by the end of this, you're not going to look at your phone the same way again. You might even feel a little respect for it. So, let's get into it. Alright. So here's where most explanations go wrong. People usually start with, computers run on ones and zeros. And then, they just stop there. Like that explains everything. But it doesn't. That's not an explanation, that's just a fact with zero context. So let's actually build the picture properly. Imagine a simple light switch. You flip it up, the light turns on. You flip it down, the light turns off. That's it. Two states. On or off. Now here's where it gets interesting. What if you had 10 light switches in a row? Each one can be on or off. Now suddenly, you don't just have two possibilities, you have over 1,000 different combinations. Just from 10 switches. That's the real power of binary. It's not about a single one or zero. It's about what happens when you combine millions, or billions, of them together. Now, computers don't actually use light switches. They use something called transistors. And the easiest way to understand a transistor is this: it's just a switch. But insanely small. We're talking smaller than a human cell. Smaller than most things you can even imagine. And your phone? It has something like 15 billion of these tiny switches, packed into a chip about the size of your thumbnail. Now pause for a second and really think about that. 15 billion switches. All turning on and off. Billions of times every second. Inside your pocket. That's already kind of insane, right? But now comes the real question. Okay. We have billions of switches. So what? How do you go from switches to watching a video? Or making a call? Or scrolling through your apps? That's where things start to get really interesting. So now we go layer by layer. Think of this like peeling an onion. Each layer builds on the last one. First layer, logic. Right now, a single switch doesn't really do much. It just flips. But when you start connecting these switches together in specific patterns, something powerful happens. These patterns are called logic gates. And honestly, the easiest way to think about them is like tiny decision makers. For example, there's something called an AND gate. It basically says, I'll only give you an output if both inputs are true. Like, imagine telling your friend, you can borrow my car only if you have a license and you've filled the fuel. Both conditions need to be true. Then there's an OR gate. That one's more relaxed. It says, if at least one condition is true, I'm good. And then there's the NOT gate. This one just flips things. If you give it a 1, it turns it into a 0. If you give it a 0, it turns it into a 1. Simple. Now here's the crazy part. With just these basic logic gates, you can build any kind of computation. Any calculation. Any decision. Anything your computer has ever done. Everything starts here. Now once you have logic, you can move to math. Because math is just structured logic. You connect these gates in certain ways. And suddenly, you can add numbers. Build a slightly more complex structure. Now you can subtract. Go further. Multiply. Divide. And when you combine a bunch of these circuits together, you get something called an ALU, an arithmetic logic unit. This is the part of your processor that actually does calculations. Every time you open an app, play a video, send a message, your ALU is working behind the scenes. Constantly calculating. But there's a problem. Doing calculations is great. But where do you store the numbers while you're working on them? That's where memory comes in. And this part is honestly fascinating. Engineers figured out how to build circuits that don't just process information, they can hold on to it. They can remember a value. These are called flip-flops. Yeah. Funny name. But incredibly important. A flip-flop can hold either a 1 or a 0. And it stays that way until you change it. Now imagine billions of these. That's basically your RAM. Your phone's short-term memory. Holding on to data while everything is running. Now we take another step. We can do math. We can store values. But how does your phone know what to do? How does it know what calculation to perform next? That's where the CPU comes in. The brain. Your CPU follows instructions. Think of it like a recipe. Number 1, load this value. Number 2, add that value. Number 3, store the result. Number 4, move to the next instruction. And these instructions are written in something called machine code. Which, yes, is literally just ones and zeros arranged in a specific pattern. Now here's the wild part, your CPU is running through this cycle: fetch, decode, execute over and over again. Millions, even billions of times per second. Non-stop. But here's where things take a leap. Because nobody actually writes code in ones and zeros anymore. Programmers write in languages that look closer to English. Things like Python, JavaScript. Simple logic like, if this is true, do that. But behind the scenes, that human-readable code gets translated into machine code. And that machine code becomes electrical signals. And those signals flip transistors on and off. Billions of times per second. And all of that is what decides what video shows up next on your screen. Let that sink in for a moment. From electricity, to tiny switches, to logic, to math, to memory, to instructions, to software, to the app you're using right now. That's the entire chain. Now that you understand the basics, let me show you a few things that most people don't even think about. Even people working in tech. First, speed isn't as simple as it sounds. You'd think faster processors are always better. And yeah, generally they are. But there's a limit. A physical one. Signals inside your chip travel close to the speed of light. Which sounds insanely fast. But modern processors are so small. And so fast. That even tiny distances inside the chip start to matter. Engineers literally have to think about how long it takes for a signal to travel from one side of the chip to the other. That's how advanced things have become. Second, your CPU is kind of guessing. Seriously. Modern processors don't just wait for instructions. They try to predict what's coming next. And start executing it early. It's called speculative execution. Think of it like a waiter who already knows your usual order. You walk in, and they've already started preparing it. Most of the time, they're right. If they're wrong, they just throw it away and start again. And this happens billions of times per second. Your CPU is constantly making guesses. And it's incredibly good at it. And third, this might blow your mind a bit. Binary, ones and zeros, isn't the only way to compute. It's just the most practical one we've used so far. There are systems being developed that use more than 2 states. And then there's quantum computing, where a bit can be both 0 and 1 at the same time. Not one or the other. Both. At once. And instead of strict logic, it works on probabilities. Now, it's not better for everything. But for certain problems, like simulating molecules or breaking complex encryption, it's on a completely different level. We're just getting started with that. So when you open an app, when you scroll, when you watch a video, what's actually happening is this. Billions of invisible switches are flipping. Logic gates are making decisions. Memory is holding values. Your CPU is executing instructions faster than you can imagine. And all of it is the result of decades, actually, over a century, of human innovation. All of that in something you carry in your pocket. And honestly, that makes you look at it a little differently. At least, it does for me. So now I want to ask you something. And I genuinely want to hear your answer. If computers can already do this much, what's the one thing you think they'll never be able to do as well as a human? Think about it. Because I have my own answer. But I have a feeling yours might be better. If you found this video helpful, hit like and subscribe to IQ Tech Nova for more tech tips.